But now assume, and that's what all these companies, like IoT companies who produce this fancy and often very great new kind of devices, let's assume we have loads of those. Of course, not only one Runtastic app and one nice wearable or watch or whatever, but let's assume we have thousands and millions and whatsoever. And assume all of these produce data. Well, that's what it's about. I'm the guy for the data. So let's assume we have loads of data, and all this data gets onto us. Yeah? And then we have the first problem. In Internet of Things and everywhere where we talk with lots of fast-flowing and fast-moving data, the first problem is to ingest all this data and to store it somewhere. So how to do it? Well, that's an architectural task. We talk about software architecture, we talk about infrastructure and system architecture. It's an architectural task. And in these days, when we talk about big data, it's a task for something new. So new kind of technology, a new kind of infrastructure, and it's not this old stuff. Yes, this old stuff might be nice somewhere, and we can maybe plug it into it, but to really ingest all this data from the Internet of Things, from what kind of device ever, it's an ingestion task. We need to have an ideal or best fitting infrastructure. So please rethink your data landscape. And everybody who's into Internet of Things or into any kind of big data issue and streaming task, first of all, think about your data infrastructure. Is it scalable? Does it scale smoothly? Am I willing to pay for it when it scales smoothly? And all these kind of things. So really important. So please not this old stuff. Yes. OK. What's next? So we have all this data. We are capable of ingesting all this data somehow. Maybe it's some sort of so-called Lambda architecture, which is in this big data application stack field, something like we have an ingest layer, we have a speed layer for real-time or on-speed analytics. We have some sort of batch layer for the regular analytics of data. And we have some sort of representation layer to actually get it to the output side. But what's next? Of course, and ideally, and that's my field as a chief data scientist, well, it's magic, of course. Yeah? We talk about magic. Some call it artificial intelligence, but let's call it magic, because for most of us, that's what it is. Yeah? In real, we talk about hard work. So to work with all this ingested data, which is often really, really noisy, it's a lot of hard work. And it's a work we know for 20, 30 years. It's like cleaning the data, normalizing the data, really work with the data, transfer it from one data format to another data format to really make it capable of actually doing analytics on it. And in the end, of course, these data have some sort of patterns in it. They have some sort of rhythms in it, so time-based patterns. They have some sort of relations, cross-correlations. And in the end, or overall, we, of course, talk about mathematics. So if we talk about Internet of Things, it's not just things. It's data, and it's mathematics. So please try to think all of these new buzzy refrigerators with data and all this technology, and of course, this algorithm side of things. And maybe sometimes we have some sort of magic. I don't know if you know this one. This is a new field in machine learning called deep learning, and it's just an idea how close we get to magic now with the mathematics. It's an automatic image classification algorithm. It was developed, I think, by Google somehow, Google Research, I think. And they were capable of throwing images unsupervised, without training, without human interpretation, into an algorithm. And the algorithm came out with these descriptions of the images. like on the top left side, a person riding a motorcycle on a dirt road. That's what a machine is saying, not a human. We'd say, oh, wow, fantastic, that's correct. But a machine was telling it us. So we're getting close to magic when we talk about algorithms. And when you love to learn about it, Google for something like deep learning and all this stuff happening at the moment. It's amazing, really amazing. They trained a deep learning algorithm now to play historic computer games. And the algorithm was capable, without training, without learning, to learn the historic computer games himself, or itself. Let's say itself. It's a machine. So itself, it learned to play these computer games and actually learned how to do it and was capable of doing all the levels and play them all. And that's crazy. A machine, without telling him how to do it and what it is, was able to play historic computer games, which is some sort of child level, but awesome. That's where we are. All right, this wording, but still, that's not it, of course. So what else do we have? We are still here. So we are still here. We are still in this Internet of Things product thing. It's just one small solution. It's I run or walk. I get all the data in my application. It gets stored in the back end, maybe for hundreds of users or millions of users, but still, it's a very, very closed ecosystem. And that's not very nice. So that's not what I think Internet of Things is about. Just some thoughts. So this is not very nice. Bah! Yeah, get over it. I don't know if you know these quokka selfies. It's an internet meme from, I think, Perth, which is a rottenest island. They have these quokkas, and people do now quokka selfies with this red kangaroo on the right. So if you Google for it, I was just laughing. I was at the most boring conferences 2 weeks ago in Vienna. It was really, really boring. And I was all the time looking at quokka selfies, and that really made my day. So if you have a bad day, Google for quokka selfies. And OK, but that's not it. So what can we do? We could build platforms. And that's what it's about. It's about open platforms, access to, let's say, all this data, for example, from people who do running or cycling or whatever. And I don't talk about data security and all these other issues. That's another task, of course, it is. But right now, let's build platform. And I was really stunned a little bit when I saw the Apple keynote a couple of weeks ago, where they actually open source their new framework, their new app for medical usage. So you can create some sort of medical test. You can use the Apple app that people can actually spend sort of their data for the medical test, and they really outsource or crowdsource medical testing in all sorts of ways for diabetes and whatsoever. And it's an open SDK, it's open source, it's an open platform. And I was really stunned and said, yeah, wow, awesome, fantastic idea. And it's sort of open source. Well, it's not said who actually owns the data. Apple is saying that they don't own the data and they don't have access to it. Well, who knows? But it doesn't matter. It's still a fantastic idea to actually crowdsource these kind of things and get a broader possibility to learn from people's health data to cure diseases we are actually working on, I don't know, for hundreds of years. So really awesome. Or we look at open data. Of course, open data. Why not make some of these data open? Not just open source, but open data. This is just a platform, City of Palo Alto, but you find a lot more. They actually open source a lot of their data that they gather in their smart cities. And you can actually use it, you can play with it, and you can actually access it. And that's quite nice. And oh, that's difficult to read. Better. That means Robo-Earth. I don't know if somebody knows Robo-Earth. Robo-Earth was the internet for robots. I think it was an international research project. They actually stopped it, so it was done, but nice. But now they outsourced this to a company. Well, you can't read it. Computer robotics sort of way, so you definitely find it. And it's the internet for robots. So the idea was that robots can learn from other robots by connecting to the internet without human help, which is a crazy idea, but that's Internet of Things. So it's an open network where machines connect to learn and do things that they are not able to do right now. For example, a robot comes to a door, wants to open the door, which is okay, might happen soon, comes to the door and can't open this lock, or can't open this door. He doesn't know how to handle the handle. So he connects to the internet, and maybe there are other robots who actually did it and know how to do it. And he learns from it, and then he's able to open the door. That's not fantasy or science fiction. That's really true, and it's interesting. So it's all about ecosystem sort of things. And did you see Baymax? Baymax is a new feature movie, and it's really nice that you have these really small robots. It's of course CGI generated, so it's not true, but it's beautiful. And if you look at these small robots, they are connected. It's a kind of swarm robot thing. So you have millions of these small robots connected in a swarm, and they act like a swarm robot thing. I saw it with drones and a lot of other things, with flying robots who act like a whole swarm of bees flying around, and that's fantastic. But still, it's a sort of a platform thing. It's an interconnection and all of this. So the question is, and I don't know if you remember this old open source book, do you want to be a cathedral in the future or a bazaar? Yeah? If you don't know what I mean, read the book, The Cathedral and the Bazaar. It's your choice, actually. Do you want to be like a closed ecosystem or an open ecosystem? And in the end, if you, let's say, want to be an open ecosystem, want to act with your IoT system or IoT solution as an open platform, then it's fantastic. You can be the service provider for your kind of services, for your data, and actually generate value for yourself and the whole ecosystem. Please don't overact. There's a new startup in the US who wants to train or use machine intelligence as data scientists, so of course don't do that, because that's my job. Yeah, so please, it's my job, don't do this, but still it's doable, and it's really, really great. So in the end, it's big data, so Internet of Things, and that's my point here. It's, of course, it is closely related to big data, and big data means not just huge amounts of data, it's fast-moving data, it's all kinds of data, it's the analytics on top of data, it's the business cases related to data, all of this is big data, and of course, Internet of Things is very closely related to it in all its facets. I didn't know the English word, or in all its facets, it sounded boring, so this is a German word, I think the only one. Take it. And yes, so please think ecosystems like this one. Yeah, beautiful ecosystem. I'm a deep diver and I love ecosystems, so whenever you come to an ecosystem, explore it. It's beautiful, it's nice, you can learn. And this one is from Connected Car. This is a movie I found on Vimeo, or Vimeo, I don't know how you actually pronounce it. It's a car crossing or a street crossing in the city. It's a simulation of it. All of these white and yellow dots are cars, and they drive themselves. So it's automated cars. They drive themselves. And if you play this video, they are just like chaotic. They are just free-flowing chaotically on this intersection of streets. There are, of course, no accidents, but it's crazy. It's like in India. Yeah? And now think of it, this is not the problem, but the problem is think that you're sitting in one of these cars. You get a heart attack, you need this other app again, probably. Yeah? But it's really, really crazy. We all know these fancy concepts about smart cities, and of course, but always when we think about ecosystems and interconnection of things and infrastructures and what kind of analog world and digital world and the transformation we all talk about, please think about people, think about users, think about the customers, think about the humans. If we think about data, Internet of Things, automation, cognitive computing, deep learning, and all of this crazy stuff, robots, please think about the user, the customer, and the human in the end. And again, do this. Think people, users, customers, humans. It's really important. And otherwise, well, maybe not otherwise, but we need to do this more and more, because I found this from Uber. This is just some sort of pseudocode, but the idea is that, of course, a lot of jobs will dissolve or won't exist anymore when we get closer and closer under the, let's say, automation API. So the more things can be automated, the more jobs we might lose. For example, my job, as I said. Chief data scientist, gone. Automatic statistician, done. Use this algorithm and you don't need me, which is OK. I can bath in the sunshine somewhere else. But yes, so it's really important. But that's not it. Or, well, it is nearly. The last thing I want to tell, and as I said, it was only a few thoughts, is that I found this interesting, let's say, a definition of Internet of Things. And it was all like, OK, it's adaptive, it's open, it's interconnected, and it's all these kind of thing. But I think it's a long way to go to actually make it happen, to have this, let's say, distinct ecosystems of devices, data, backends, to really speak to each other and make it really some sort of smart, I hate the word smart, but some sort of smart system, like a smart city, a smart workplace, a smart company, a whatever smart, a smart holiday destination, I don't know. But really, it's a long way, and this is where we start. So thank you.